matrix A and matrix B can only be multiplied. It works better when you have a pen. But they can only be multiplied if the number of columns, I can't write just yet, all right, so if the number of columns in matrix A is equal to the number of rows in matrix B. Now, to multiply matrices together, they do not have to be the same size. When you add and subtract them, they do, but when you multiply them, they do not. But there is a rule that you have to follow to determine whether you can multiply or not. So if matrix A has the dimensions m times n, rows times columns, and B has n times p, then the result is m times p. Okay, so basically what happens, and you have to do it in order, whatever matrix comes first. So if I'm multiplying A times B, I'm going to write the dimensions or the order of matrix A first. Then I'm going to write the dimensions of matrix B. Notice how these two numbers are the same. The number of columns in matrix A equals to the number of rows in matrix B. That's what that statement says. If that is true, the outside numbers, that's how big the matrix answer will be. That's how big the product will be. Okay, so in the first set of examples, all the rest of the way down to the very bottom of the page, we are going to determine whether we can actually multiply these matrices together or not. Okay, so I need to know if I can multiply A and D together. If we can, I need the dimensions of the resulting product. Okay, so what are the dimensions of A? A 4 by 3. What are the dimensions of D? A 3 by 1. So if I'm multiplying a 4 by 3 times a 3 by 1, if these two numbers are the same, these two numbers represent the answer. So yes, I can multiply them together because the middle numbers, these numbers are the same, and my result will be a 4 by 1. Okay, now in number 2, we said that A was a 4 by 3. And what's the dimension, or what are the dimensions of matrix C? 2 by 4. These numbers are not the same, so no, you cannot multiply A and C together. All right, dimensions of B, a 1 by 5. And if you multiply that by E, which is a 5 by 2, these numbers are the same, so that represents my answer. So yes, I can multiply them together, and my answer is going to be a 1 by 2 matrix. That means one row with two numbers in it. So I'm going from all these numbers and all these numbers to 2. Crazy, isn't it? Your answer, one row, two numbers. You start with this, and I end up with two numbers. That's it. Okay, so 4. We said that B was a 1 by 5. We said that D was a 3 by 1. We cannot do that one because those two middle numbers, so we cannot multiply B and D together. All right, so I'm going to pause for just a minute and give you a moment to answer 5 through 8. Any questions? All right, now the process that you have to go through to multiply, this is where it gets tricky. Now, I know that this is a 2 by 2 and this is a 2 by 2 and they're the same dimensions, and that's okay because a 2 by 2 times a 2 by 2 produces a 2 by 2. But that's not always the case. We had a 3 by 5 up here. We had some other things up here that were not squares, okay? So how this works, all right, my answer is going to be a 2 by 2. That means 1, 2, 3, 4 numbers. I have to calculate 4 numbers. Now, it doesn't matter if the matrices are bigger than a 2 by 2, smaller than a 2 by 2, different dimensions. As long as you say yes, you can multiply them. There's a method to the madness, okay? So we're going to use the rows from the first one and the columns from the second one. Rows from the first one, columns from the second one, okay? So what I'm going to do you agree that this is row 1, column 1? This number would represent row 1, column 1. So I'm going to use row 1 and pair it with column 1. How I do that is I multiply the first numbers together, so A times E, then I will add B times G. So go across the row, down the column. Notice there are 2 numbers in that row, 2 numbers in that column. Pair the first ones, pair the second ones, add those together. All right, so when I move over, I am now to column 2. First row, now I'm going to pair those with second column. So that would be AF plus BH. You go across the first one, down the second one, okay? Use the rows of the first one, pair them with the columns of the second one. So now I'm done with my first row. I do not need those numbers anymore because I'm done with row 1. So I'm going to move on to row 2. So I'm going to pair C and D with E and G. So that would be CE plus DG. CEDG. What's the last pairing? CF and DH. Okay, now I want you to kind of look at this for a minute, and when we start putting the numbers in, it's going to make a lot more sense. When you look down this column, do you notice you have E's here and G's here? Over here you have F's and H's. That's going to work every time. It's going to be a lot easier to see the numbers with it, okay? You'll be able to pick up on how the patterns work. Now, we're not going to do both 9 and 10 because the pattern is the same for 9 and 10. I am going to do number 9. It is a 2 by 2. But then if you notice at the bottom, we start getting all kinds of weird sizes, okay? So we already said a 2 by 2 times a 2 by 2 produces a 2 by 2. So I need, and this is just me, you don't have to do it this way. I need a 2 by 2. 2 rows, 2 columns. I got to find 4 numbers. Okay, so in order to find the first number, this is just me. You don't have to do it this way. You can do it a little bit different, however you want it. But I'm going to take these 2 numbers and pair them with these 2 numbers. So that's -4 times 6 plus -9 times -5. I stick with 1 row. I do my 1 row with every column. So I'm going to take those two numbers and I'm going to pair it with these two numbers. So that would be -4, -1, plus -9 times 4. We'll get all those numbers in just a minute. Now, I am done with the first row. Remember, you use the rows in the first matrix. I'm completely done with the first row. So I'm going to take my 3 and my -2 this time and do the same thing. So 3 times 6 plus -2 times -5. See how my 6 and my -5 line up? That's what I was talking about with the letters. Over here, I'm going to pair 3 and -2 with -1 and 4. So 3 and -1 plus -2 and 4. See how these second numbers line up? Now you just got to do the math. It's tedious, it's time consuming. Lots of room for mental mistakes if you're trying to do this, mentally. What if you multiplied that together and left it a -45 instead of a +45? So there's lots of room for error. So be very, very, very careful. Now, when you do this, all of this right here, you should get 21. When you do all of this right here, you should get 21. The next group going across, you should get -32. When I do this pairing, all of this, order of operations, multiply, then add those numbers together, I get 28. And then the last number is -11. So I'll give you just a second to process all that. So this would be my final answer. That's a 2 by 2 matrix. Y'all agree? All right. Any questions about that? I'm a visual. I have to see it. If you can do it without it, by all means, go for it. If you're one of those that can keep 15 numbers straight in your head, that is great. I admire you because this chick can't do it. Okay. I got to see it. I can keep it straight if I see it. I just don't see it in my brain unless it's on paper. All right. So number 11, that's a 2 by 3. You are multiplying by a 3 by 1. Do y'all agree? So how big should my answer matrix be? A 2 by 1. That means 2 rows, 1 column. So 2 rows with only 1 element in each row. I am going from all of this to 2 numbers. Okay. So this is how my brain works. I need 1 number here, 1 number here. So let's go through it. If you notice, the number of elements in the row here just so conveniently happens to match the number of elements in the column here. So instead of pairing 2 sets of numbers, we got 3 sets of numbers we got to pair. So -7 and -6, you're going to add that to 2 times 4, and then add that to -11 times -3. Go across the row, down the column. That's going to give me the first number in my matrix. Second set, I'm done with this row. We only needed 1 number in the first row, so I'm done there. I'm going to take those bottom 3 numbers in that second row, pair them off with those 3 numbers in that column. So that's 3, -6, -5 and 4, -2 and -3. Now, even here, my -6 is lined up, my 4 is lined up, my -3 is lined up. The only thing that's different are those front coefficients. So when you do the math across the top, you should get 82. I'm sorry, 83, not 82. My bottom number is a 2. Negative 32 for the bottom number. So that is my 2x1 answer matrix. All right. Everybody good there? We're going to do 13 and 14 next. All right. Not going to do number 12, but we're going to do 13 and 14 next. 13, I have a 2x2 times a 2x3. I can do that because these two numbers match, so my answer is going to be a 2x3. Now, don't have enough room right there, so I'm going to put it over here. 2 rows with 3 elements in it. 1, 2, 3, 1, 2, 3. So I'm looking for 6 numbers. Kind of weird. Do the same thing over and over. 1, 2, 3, 1, 2, 3. So I got to do all my pairs or triples or whatever. So if you notice, I have 2 rows in the column, or 2 elements in the column row, and 2 elements in every column, so they match up. So that would be 9 times negative 3 plus negative 5 times negative 1. Then I'm going to pair 9 times 13 and negative 5 and negative 7 together. Second column. Go to the third column. 9 times negative 5 plus negative 5 times 2. So I'm done with my 9 and my negative 5. So now I'm going to throw in my negative 2 and my 4. Go across the row of the first one, down the columns for the second one. So negative 2 times negative 3 and 4 times negative 1. See how my negative 3 and my negative 1 are lining up? Then I have negative 2 times 13 plus 4 times negative 7. Then negative 2 times negative 5 plus 4 times 2. Once you get everything in place, you can put those numbers in. All right, I have negative 22, 152, and negative 55 going across the top. Bottom row is 2, negative 54, and 18. So there are my 6 elements for my 2x3 answer matrix. Any question about that? I told you it wasn't hard. I told you it was tedious and time consuming, correct? Not too bad. We have done harder things in this class, all right? It does take a lot of patience and it does take a lot of time. Now, can I do number 14?
Yes.
What are the dimensions of the first one? A 3x1. What are the dimensions of the second one? How big's my answer going to be? So we're going from 3 numbers and 3 numbers to 9 numbers. My answer matrix. No lie. 3 rows, and each row has 3 elements in it. 3 columns. Dun, dun, dun. Nope, I'm going to help you with this one. So I am going to come back over here and erase number 13 because I need some space. Because I need 9 numbers this time. All right, so here we go. 1, 2, 3. 1, 2, 3. 1, 2, 3. Across the row, down the column. That row has one element, that column has one element. Negative 14. There's no other element to add, right? I have one number in this row, one number in this column. So go across row, middle column. So that's going to be 14 times 9. There's no other number in the column or the row to pair. So we're not having to do all the adding that we did up here. So right now I have negative 14. That middle number is 126. Then I'm going to take that 14 and pair it with my 5. Because that's the last number. It's the last column. That gives me 70. Top row is done. I do not need that 14 anymore. Start with your second row. Negative 2 times negative 1. And I'm going to go back up here and write this so we can see. That was 14 times negative 1. That gives me a 2. Then I have negative 2 times 9. And then I have negative 2 times 5. So I have a negative 18 and negative 10. And then negative 6 times negative 1, negative 6 times 9, and negative 6 times 5. So 6, negative 54, and negative 30. That's how it ends up being a 3 by 3. I did not have to do any of the multiplying and adding together because each row and each column had exactly one number that you paired off, not multiple numbers. Okay, any questions about that? All right, before we keep going, I'm going to pause. I'm going to let you come up with the answer for number 15 on your own as adding or subtracting matrices. Okay, for adding and subtracting, have to be the same size, element to corresponding element. But when it comes to multiplying a matrix times another matrix, certain conditions have to apply. Now, in this last example, it asks us to give our given matrix A and matrix B to the left, find AB and BA. What can you conclude from the results? Okay, so I'm going to help you with the AB one. I'm going to help you multiply A times B, and then you're going to do B times A, and then we're going to try and figure out what's going on. Okay? So to multiply A times B, that's a 2 by 2 times a 2 by 2, so I need a 2 by 2 out. So row, column. So that's 3 times negative 2 plus negative 1 times 7. Go to the second column, 3 times 10, and negative 1 times 6. So I'm done with my first row. Same thing with 4 and 8. So 4 times negative 2 plus 8 times 7, 4 times 10 plus 8 times 6. So I end up with negative 13, 24, 48, and 88. Okay, now if I switch these two, do you think I will get the same matrix?
No.
That's right. Okay, now this is called commutative property, and we did this before. where you have 2 times 3 and you can change it to 3 times 2, and that's still the same thing. Do y'all agree? This does not apply when you are multiplying matrices together. When you reverse these two, when you go back and you do the rows of B paired off with the columns of A, you will not get this answer. So AB does not equal to B times A. Okay? If you want to go through just to practice your skill, the outcome for AB is going to be 34, 82, 45, and 41. Definitely not the same as A times B. So B times A, that's the final outcome. Mm-hmm. Yep. Now, see, I'm weird. I have to see it this way. So I'm going to do my -2, 10, 7, and 6. Whatever goes first, I just need to see it first. So I know I'm putting these two numbers with these two numbers. So that's -2 times 3 plus 10 times 4. So if they reverse order, I have to switch them. I'm a visual person. I have to visually see it. If you wonder why I give so many examples, because I want to make sure that I get to my visual people. Everybody good? All right. So now you have one homework assignment left. Most of you got your intro to matrices done the other day. You have 45 minutes today because we have finished